Good afternoon, everyone. Let's start today's ConSteel webinar, which will be about the ConSteel programming interface and the developments made in ConSteel 13. I am going to be your host today. I am Roland Doka. I am working as a product manager here at ConSteel Solutions Limited. Some practical notes about the tool we are using, which is GoToMeeting. You can hide the side panel with the red arrow button, and we have uploaded a handout for this webinar, which you can download at the handouts menu. And also you can ask questions on the go if you want, and we will answer that. If we have time, we will answer that at the end of the webinar, or if not, we will handle them via emails. What will be the content today? We will quickly go through that. Where are we standing in our ConSteel 13 webinar series? We will go through the ConSteel programming interface developments. Each function will be highlighted, and also I will give you some more useful information at the end of my presentation. Currently, this is the middle of the webinar series of ConSteel 13. We have two webinars organized last week and the week before that, the What's New webinar and the section drawing webinar. These two webinars are already uploaded to our website, to our YouTube channel, and we will have one more webinar next week, which will be about the design of code for members, the main function of ConSteel 13, the menu function. You can register to that webinar at our website, basically, below supports and webinar label. Okay, and now let's see what are the developments regarding to CSPI. ConSteel programming interface basically was introduced in ConSteel 11, where with ConSteel programming interface you could do parametric modeling. You could build up models based on scripts you write, and after that in ConSteel 12 we introduced some new functions like debug and some troubleshooting functions such as automatic code check, and the debug function was the main new function itself. And in ConSteel 13 we have basically two new big functions, the analysis and design functions, which can be now executed from the code. And then with the already existing basic programming tools you are able to run, you are able to create scripts which optimizing the structure you have created or existing structures in ConSteel. So from ConSteel 13 we will have two commands to run analysis and design, two commands to get results from the analysis and the design, and also we had to develop some additional commands which are necessary in order to be able to run these new functions, analysis and design functions. Okay, so how you can, what is the let's speak about these new functions. Basically, with the analysis and the design option, with the analysis function, you are able to run first order, second order backlink, second order analysis. You are able to run backlink analysis with the desired number of backlink shapes, and also you can run dynamic analysis also. And then with a separate command, you are able to get results from these runs. This is true also for the design itself, and basically what you can set in ConSteel at the design tab of ConSteel, those can be controlled via script. And also in the optimization side you will use, or we have to use basic programming tools such as loops, cycles, and proper use of variables and arrays, which we will talk about later, and I will show you in a live example in my presentation. And there is one new, I think, important command that now we can write data into Excel, not just read data like we could do that before, but now you are able to write data into Excel. So let's see what are the new additional commands in CSPI. These commands were necessary to be developed in order to be able to run the analysis and the design. So now we are able to create mass groups. When you create a new, these commands are basically new functions for the create command. So now you can create mass groups if you give a name of it and you define the type of your mass group. So it is a permanent, variable, or snow mass group. These are the settings you have to make in order to be able to create a new mass group from script. And actually you will find from all of these commands, sample codes in the released handout what you can download. Okay, now we can create mass case. If you create a mass case, the information you have to give when you use the function is that what should be the name of your mass case. This is an optional attribute, so if you don't set it, ConSteel will name it with the default name, but you have to define that which is the mass group do you want to place your mass case into. Usually this is done by ID, but you can reference the mass group with its name if you want that. Also, you have to set the seismic direction and the free vibration directions, so which directions should be considered in these mass cases. We can also create node masses, and when you create a node mass, basically you have to add as an information that in which mass case do you want to include this node mass. And also you have to give the coordinates, global coordinates of the node mass and the mass value in kilograms. Okay. We can create load combinations by hand basically if you want that. So if you have existing load cases in your model and you want to combine them in a way that you feel good to, you can do that by simply referencing to the load cases by their IDs and then adding the combination factor after them. Also, we can generate load combinations, so all of those load generation options which are in ConSteel can be used with the generate load combination command. And as I said it before, we can write data into Excel now, which is really straightforward. You have to, after you write the command itself, you have to reference that which is the name of the worksheet you want to work into, write data into. You have to say that which is the column and which is the line where you want to write your data. And the data itself can be numbers, texts, and also number or text stored in variables. But the first two big functions are the analysis run and the design run functions itself. In these functions, for example, in the analysis run function, you have to set basically what is implemented into this command is the content of the analysis parameter dialog in ConSteel. So you have to set the type of the analysis, elastic or plastic analysis that you want to run, and which combinations do you want to use for your analysis. You can choose, if you name combinations by their IDs, you can only do the analysis for those combinations. If you don't do that, all of the combinations will be used. This is true for the load cases and the mass combinations also. And what type of analysis you can run is basically first order, second order, buckling analysis. Here you have to define the shapes of the number of the buckling shapes. And also you can run buckling with sensitivity. So you can run sensitivity analysis. And dynamic calculations are also available for this command. When you use the design option from script, you have to set that what results do you want to use from the analysis, first order results or second order results. Again, you have to set the combinations do you want to use, specific combinations only or all of the combinations. You can run backlink check, cross-section check, beam or column reinforcement checks, and also composite column checks can be done with this script. You can set the parameters you find on the design dialog in ConSteel, so you can set the elastic critical factor, how should be, which alpha critical value should be used when you run global stability check. So the first and the lowest alpha critical value should be used, or what is selected during the analysis, or automatic, which is basically the sensitivity based global stability design. You have to set that how the ultimate resistance factor should be coming from by member or from portion, and also you have to set the reduction factor, how should be it evaluated. And then we have two more commands, the get results analysis and the get result design command. So as you can see, this is the syntax for the command. In the first line next to the command you see these bold texts. Basically the result of this command after you perform it will be some variables. In this case 1, 2, 3, 4, 5 variables. The first variable will be created by this name. In this case result var will be the name of that variable, what will be created after you run this command, and the command will fill up this variable with the result regarding to these settings. So if you set the type of analysis what you want to get results from, elastic or plastic analysis, you give filters that what kind of sections do you want to get data out from them, or what only certain type of materials should be used for the get result command, or also what combinations do you want to use, what type of results are you interested in, deformations, forces, stresses, reactions, and some location info such as minimum, maximum values, and from certain distance from an end point or a start point of a member. You can give that via ratio, so it will this ratio have to be a value between 0 to 1, and also you can combine it with different parameters, different result types if you want to. So basically that based on these settings you will get a variable, and in this variable the command will store the results of this command. Also you will get the ID of that specific object, which is where this result comes from, and you will get the coordinates of that result also. This is also true basically the get result design function. So the work, the syntax is more or less the same. Okay, now let's see how these commands work in action. First, I will write a script, an easy script which will use these new commands. So as you know, maybe the CSPI Editor is located down here at the bottom left corner of the screen. If you open it, this is the editor and which will be opened. Here you can write your script, and with the run button you will be able to run your script after you finished. You have a backward and a forward button. You can save your script, or you can load pre-existing scripts. These functions, what can be found here in this layer, are basically the debug functions. So you can place points into your script, debug points into your script, in lines where do you have some commands, and when you run the script, the program will stop on that line. Every variable which is defined until that point will be listed here in the watch window, and you can go line by line and examine what is happening inside of your script. So if you have some troubles running your script, or script is not behaving as you want to behave, you can check it with the debug function and go through of it line by line. Okay, but that's all. These were of course already existing functions. Let's see some new stuff. First, I will quickly build up a basic a simple beam where I will have a span of 5,000 millimeters, for example. This is how you define variables. So you will start with a dollar sign, and then you will give a name to it, and then you define the value of it. Variables are I have a color of this purple color. Commands are highlighted with this yellow or orange color. I will define a node force, a point force on my beam, and I will do that with a variable again, which will be 135 kilonewtons. Okay, and now let's start the creation of the structural member. First, I will use the create command. Then I have to add an ID for this bar member, which will be now given manually, and I will use this simple M1 because I don't. Yeah, this will be the ID. Normally, in more advanced scripts or in scripts which is not handles only one bar member like I want to do right now, but more complex scripts, IDs should be given by variables, not by hand, of course. But you can do this right now. Okay, the structural member is the command I can use to create a beam, and I have to set the section for it. Again, I will add it manually. These are the start point coordinates, and these will be the end point coordinates. Then, if I have my beam, I need some supports placed onto it. So again, I will use the create command. I will give an ID of support 1. Function is support point. I have to add that which is the ID of the member on which I want to apply my support, so it will be M1. And then the type of the support will be X, Y, Z, and XX type of support. And the coordinates has to be set, and it is located in the start point of the member. We have one more supports to go. So again, create. This will be the second support on M1 member, and the type of the support will be Y, Z, and XX. And the coordinates will be the end point of the member. Okay, and then lastly I have to add the node force. So I will type create force 1 as an ID, node force will be the function, and I have to say that in which load case do I want to place my node force. So it will be name, well, this is the name currently. I could reference the load case via ID, but because this load case is currently the default load case in my program, I can reference it with its name if I so that is how I do it right now, and I have to tell that on which member do I want to see this force. Again, it's the M1 member, and the coordinates is span/2 0 0, so this is the middle point of the member, and the components, the force components, will be 0 in x direction, 0 in y direction, and the F force in the z direction. The bending moment components will be 0 right now. Okay, so let's see what is the result of this whole script so far. Yeah, this is what I wanted to see. Load is placed into that load case. Okay, so these are not new functions, of course. Let's move on to the analysis run, how we can initiate analysis from the script. First, we have to use the analysis run option, and we have to type that what should be the type of the analysis. It will be an elastic analysis right now. It could be plastic also. What is the load combination do I want to use? Again, because I have a default load combination by the name of this, I will use that and reference it via its name. So load combinations will be name. Okay, and now we have to set that what type of calculation do we want to perform. First order, second order, buckling if you want to, with how many buckling shapes, and basically this is how you can do that, how you can set up your analysis. And if we click on the run button, analysis will be performed. First order, second order, and buckling analysis. Everything works the same, so we have the values coming from the analysis available. And let's see how we can apply a design for these results now. So the next step will be adding the design run function. The type means that what are the results that we want to work with the design. It will be first order results from the analysis, and again we will set the load combination, which is this one again, and we will do a simple cross-section check. If you want to calculate buckling analysis, we can type it too. Stability analysis, we can type it, but now I will stick to the cross-section check only. And if we click on the run button, we will get the utilizations. Just as we would do it with manual data input. Okay, next step is to basically optimize this member. So how you can do that? First, what we will have to do is to load some more cross-sections into the model. And how we will do that? We will create an array. An array is basically a list of variables. And how you can define arrays is basically you have to type the array set function, command. You have to define the name of your array, which now will be sections. You have to define that which is the index in the array. Do you want to give a value? It will be the first one, and then you have to type that what do you want to store in the first index of that array. So it will be an HEA 200, for example, and we will do that some more times. On the second index we will have a H220, on the third one 40, and so on. Okay, this is the first one, what we have to define. Let's add a variable which will be used later on in our script as a pointer to into the array. So let's define array pointer variable, and it will be 2. That means that what I want to use this variable for is to define this value here, because basically this is the second value of the array, because if I would do it properly, the first value of an array would be the 0. This is it counts from 0, so this is why I typed 2, because this is the second one and this will be our start section. Okay, and let's scroll down because we have to perform more analysis runs after each other. How we do that? We will create basically a loop for the start, but before we're doing that, let's create an if-else statement which will be used if the utilization is higher than 100% of utilization. The script should change the cross-section of that section. So we will start with an if statement, and then we will close it with an and if. And we have to define that what should happen in this statement, in this branch. So we will define a utilization variable, and if it is higher than 100%, we have to tell that what the program should do. So we will do that if the utilization is higher than 100%. We will use the array get command to get information out of an array. We will use the sections array, and we will use the pointer, which is basically now the second index of the array, so it is a H200 section, and then we will store this value into the section variable. After that, we will load the section, and then we will use the set command to set the M1 member, to change the cross-section of the M1 member by its ID, structural member, and what should be changed is the section. The new section will be what is stored in the section variable. Okay, and that's all. And yeah, this is will only happen once because it is not in a cycle yet. How we can define a cycle? We will use a for cycle basically, and for that for cycle we have to use a running parameter, which will be, for example, $P. This will be a running parameter. It will start with a starting value of 1, and it will run where we can define that do we want to run 3 times, for example, 5, 4, or any times. So this is the number of iterations, but maybe it is better if you define it with a variable, iterations. And yes, after each iteration, basically if the utilization is higher than 100%, we will have to increase the value of the array pointer, because this is how we can jump to the next section in this array. So this is how we can jump from each section to the next one. So we will type $pointer +1 at the end of each cycle. Okay, and we have 2 undefined. Oh, something is missing. We don't know what is the utilization yet, so we have to use the getResult command. So we will use the getResult. We will get result from the design, and we will create a new variable. So as you remember, the outcome of the getResult design command is a variable where the utilization now will be stored. So I will call it utilization, and the result type will be the dominant utilization from all of the bar members and the maximum values. Okay, now we have defined our utilization variable, but we are missing the iterations variable. So we will go back to the beginning of the script, and let's say we will iterate, for example, 3 times. This is a very basic script. You can, of course, you can choose to write a script that iterates itself until it's necessary, not just 3 times, 4 times, but until it's necessary. Okay, and I think we have everything. Let's see if it is working or not. Okay, this is the first round of design, and then the cycle will do its job and then change a section, and as you can see, the utilization is dropped now to below 100%, and the section of that member is, this is the end section. Okay, so this is how you make a very basic optimization script for a model which you built up from a script. But what's in those cases when you already have a model and you want to initiate some kind of optimization? There is currently one drawback to do this, because first you will have to load some cross sections into the CSPI, and then you can do your optimization script. But there is a command what you can use. So I will delete my, actually let's start a new model and do it from there. This will be much shorter. Okay, just very quickly. Create a bar member by myself, not with script but with hand. Okay, for example, this one. I will add some supports and then some loading to it. Okay, so it is not made via script but with hand. And then let's copy paste this previous script and use parts from it. So we will don't need the create command at all. We don't need the span, and yeah, we won't clear the model. Okay, so there is a function what you can use and which is very useful in these cases when you want to define that what are the parts of the model that you want to run the optimization for. So this is an already existing function but can be used now. So the get user input command is what we will need now. The object will be the attribute what we need, and what this command do, it will give a dialog to the user. There will be a select button and the user can select those members which the program will gather their IDs of the members, store them in an array, and can be used later when referencing them in a script. So we will define an array, the member list, and we can add the command that please select beams for optimization. Okay. And then we will need something else also, because when we are here at the utilization, and here when we are setting the cross-section for the member, we now don't have the M1 member in our script, we have something else, but stored in an array. So we will need another array get function. Actually, we can do it currently right here. Array get. We will need the member list array, the first value of it. Of course, now it is a one. It has only one value stored in that array, and we will store what this command finds there in an ID named variable. And then if we go to the set command, now we will be able to use the ID as referencing to that member. Okay, and basically that's all what we have to do. If we run the script, we will get this dialog. We can select one or as many members as you want to, and then if you click on with the right mouse button, the objects will be selected. I think I had something below that beam, but after you click on the OK button, the script should be running, and yeah, something is not okay now. But anyway, we only get the second order model instability. First order will be initiated, I think, properly. But what I wanted to show you is basically how you can gather IDs from an already existing model. So in this way you can write scripts which are not based only on the model you have created via CSPI, but already existing models. And I will show you one more script which is already built up, and I will only show you how it is performed, because I want to show that how you can write data into Excel. And as you can see now, something is missing from my script. So I made some mistake. I will check that. After it's finished. Okay, actually let's move on, and I think what I wanted to show you is shown. So this is the command that you can use in models that are already built up. And the last script I wanted to show you is basically this one. And in this script we will use the Excel write cell command to write out data into Excel. And what this script does, it basically will give you a dialog on which you can set, basically this is a macro for this truss you can see on the picture. We can add the height of the truss, for example 2000 millimeters, and the span, let's say 13,000. We can choose that if we want to see a 4, 6 or 8 number of divisions in regarding to the truss. We can add the forces on the sides and in the middle, and we can set utilization limits, lower and higher utilization limit, I mean upper utilization limit. And then after you click on the OK button, this macro will be built up, Excel will be opened, and then what will happen, of course, the program will run the analysis and iterate until it finishes with the utilizations. And in the meantime, in the Excel file, data is written out. These columns means these are the IDs of the bar members, and each row is a utilization row. Each column is basically one column, and then the results of one bar member. So this is the first utilization after the first iteration. This is the second utilization after second run of the design, and this is how you can get the result. Currently there are 4 more bar members, still has to be optimized. Okay, we have one question received. Is it possible to optimize members for local deflection check with the current functions you have developed? Well, you can get results from the analysis, deformation results also, and based on these results you can make certain type of changes on your model. So you can do that if you write a script for that. Yeah, you can do that. There is a way to do that. The functions are available to do that, but you have to write the whole script. Okay, the script is finished. Let's go back to the presentation. Currently, if you go to our website, you will see that a beta version of ConSteel 13 is released, and you can do that. You are free to use it. Or customers who has maintenance on their ConSteel 12 license are already received the configuration file necessary to be able to run the 13 version of ConSteel. Those who want to test this version, the 13 version, just and don't purchase ConSteel yet, just ask a license for it with softkey@consteelsoftware.com, and we will send you a test license if you want to test it. Of course, this is it would be good for us because in beta version we are still testing the software. Some bugs can be hidden, what has to be revealed, and if you can help us with that, that would be appreciated. If you find bugs or have any comments on the functions that maybe what modifications do you want to see in the future or something like that, just write these comments to support@consteel.atlassian.net. For press quotations and other information, just use the traditional info@consteelsoftware.com email address. Okay, and in the meantime we received one more question. Is it possible to optimize, this was the previous, so you would have to get the displacement at the end of the beam and the maximum deflection of the beam and compare the deflection ratio to the limit. Yes, exactly. Okay, well, if you have any more questions, just feel free to send us email to the support address and we will answer them one by one. Thank you for your attention and see you next time on next week's webinar, which will be about the cold-formed design function in ConSteel 13. Goodbye everyone.